Thank you, Michael. It's wonderful to be introduced by such a close friend, family member almost, I guess, yes?
Yeah.
And there's so many friends in the audience, so many familiar faces. Thank you for coming tonight. So I'm interested in drawing as a verb, the act of drawing. As a scientist, as a geologist, as a museum curator, I draw to see. I draw to see more clearly. In this case, I'm drawing a 200 million year old skull of an animal called Hypsognathus from the Blomidon Formation. And as I'm drawing it, I'm looking at it as a paleontologist. I'm looking at it to see where the suture lines are, where the lines between the individual bones. I'm also looking at it to see what bone was broken and isn't preserved, what's been bent and twisted. Another example at the museum is a 300 million year old plant fossil from the Carboniferous period. So while drawing that specimen, I can notice whether the edges of that particular leaf are preserved or not, whether it's been broken, whether an insect might have been eating it, whether the tip of the frond has been broken and twisted. I'm looking at the actual thing to try to see what I can see and what is observable from this plant that was in a state of decay 300 million years ago. It was being twisted and broken and in decay, and was quickly buried by sand and preserved for 300 million years until we came along and collected it. I'm very privileged to work at the museum where it's not only I have in charge of collections that are hundreds of millions of years old, but this specimen was collected in 1867. Or slightly before, but on display in Paris in 1867. So 3 million people would have seen that fossil at the time at the exhibition, and this represented Nova Scotia. And now the world is coming here rather than us taking things to the world. And what a privilege it is for me to speak to you about the Geopark, but also about the amazing event that you have here, where you're looking at the geology through the painter's eye and the painted brush, looking at our beautiful landscape. So these are the locations where the 30 artists have come from and come to the Cliffs of Fundy in the Parrsboro area, so scattered all over North America, coming to the Plein Festival, the Parrsboro International Plein Festival. What a wonderful event. What an amazing way to share this place with the artists all over North America, who will then take these images back and who will be sharing their images on their social media feed. So, we are here in the Cliffs of Fundy. It is one of 229 UNESCO global geoparks, and as Michael was saying, it's more than geology. It's these geoparks that are scattered around the world do have significant and really important and inspiring geology, but they also have rich culture of art and food, of language, of music, and it's all related and interwoven with the geological history of these places. So we're very proud to have the Cliffs of Fundy as one of 5 Canadian geoparks. And would encourage you to stop by the office and to also look up their website, fundygeopark.ca. And I just we'll be talking to you tonight about the overall geology that the artists will be experiencing during the festival and how it relates to the Geopark. The Cliffs of Fundy is a space from Truro to Advocate, and there's geosites all along and the main pillars that support the Geopark, main themes that run throughout all of the different sites within the Geopark and the region of the Geopark from a geoheritage point of view, are the amazing tides that we have, the world's highest tides. As the artists are out there painting, I will really encourage you to, as you start your painting, if you're by the shore, look at a rock and just notice where it is while you're painting. Then turn around 10 minutes later and see that it's gone. Choose a rock higher up the beach if it's rising, if the tide is rising. It's an incredible experience to feel the water rising or falling, to see the amount of power that is coming in that's driven by the moon. So that's one of the themes of the Geopark, is the highest tides in the world. Geologically, it's also the assembly and breakup of the supercontinent called Pangaea. So I'll be talking to you about that. And this is also a part of Mi'kma'ki, the home of the Mi'kmaq for more than 11,000 years. So that's where we'd like to start in terms of recognizing that we are in part of the larger area of Mi'kma'ki, and this is the traditional and unceded, for visitors who might not be aware, the unceded territory of the Mi'kmaq people. And we are grateful to be here through the agreement of the friendship treaties. So we're all these are still active relationships. We're all treaty people. One of the inspiring things that I find I carry through a lot of my work at the museum and in general is the idea of two-eyed seeing, or tugdalump. So I put up my Anglophone-ized attempt at pronouncing that Mi'kmaq name, tugdalump. So the idea was put forward by Elder Dr. Albert Marshall that as humans we have two eyes. And it's not that we have science and traditional knowledge, and one is right and one is wrong. We can look at both through one eye. And what I love about this, not only from appreciating Mi'kmaq culture much more fully, but I think an artist can also, while they're creating their art, which is based on emotion and the feeling you have when you're confronted with the landscape that you're trying to capture, you can also, through the other eye, look at the geology and hold both of those things together at the same time. Reverend Silas Rand was the first person to really learn the Mi'kmaq language and write down the legends of the Mi'kmaq. And this is published around 1880, 1890. And Elder Gerald Glode has taken a lot of this work and identified the place names around Nova Scotia which relate to these legends of Glooskap that Silas Rand was one of the first to document. And one of the really important sites is Partridge Island, known by the Mi'kmaq as Sayuk. And Gerald Glode is a Mi'kmaq elder, but also a very talented artist and educator. So this is his depiction of Glooskap and grandmother at Partridge Island, and Glooskap giving grandmother a necklace of amethyst, which can be found at Partridge Island. And it's known as grandmother's cooking pot because as the tide rises, the water will boil at high tide. It bubbles from air trapped below. So this is an important place for the Mi'kmaq and for all of us. So I'd just like to take this opportunity to let Gerald Glode tell us about this area.
At the point of time when the stories of Glooskap originated, this land bridge was not connected to the island. This land bridge was basically just deposited here in 1869 by the Saxby Gale before the island was only accessible at low tide. And in the old Mi'kmaq maps, you talk about a place that this was called was Wazok. And Wazok in the Mi'kmaq language is heaven. It's like, why would you give such a place such a significant name? And then here you find with all these materials that are here, it would definitely be heaven on earth. Just to find like all the materials that you needed in order to survive. All the different nappable materials you needed to fashion tools, the volcanic basalts that you use for your fireplace, and the grandfather stones for sweat lodges, and even hematite, which we use for red ochre, and even was a part of our burial ceremonies at one point. You're finding all these significant materials right here on this island.
Hey, Gerald.
So next, from focusing on Partridge Island, there was an article that has just been published in the recent edition of the June-July issue of Plein magazine that focuses on quite a bit of the pictorial history of Partridge Island. It starts back to 1777, which is the oldest image that I was able to come across on the right-hand side there of the western side of Partridge Island. And I'll talk a little bit about the others. The one on the top left from 1817, that done by George Heriot, who was the Assistant Postmaster General for Canada. And the one on the bottom was done by a surveyor, John Elliott Wolford. So the images of the time were done by map makers, surveyors, people working for the postmaster, traveling the landscape. So these are the talented people that were skilled in observation and map making. And then the top image of from Partridge Island looking towards Cape Split was done by Alicia and Jeffries, who this image was published in a geological book by Abraham Gesner. So the images of the area were produced and published by surveyors and map makers and geologists. Then the article also includes the modern images of the wonderful Plein Air Festival and Gerald's artwork. The Plein Air magazine does have other articles for the artists in the room. You can just look up What the Rocks Tell Us. There's a 22 article series that was published in the Plein Air magazine by Brad Holt, who had an undergraduate degree in geology, and then he became an artist. So another example of this crossover between art and geology. And I love this quote that it's not required that artists learn about geology, but artists are intelligent and curious people who are likely to find geology interesting, which I think is very true. So taking those images from that article, I created a Google Earth view and hopefully it's not too nauseating for people to watch this. We're going to zoom into Partridge Island to these different vantage points, because that's the thing with art, is where are you located and what are you looking at? So with Google Earth, I can zoom in and I can then pan around to see what's visible from a particular point of view. And in this case, we're looking at the vantage point from 1777, and that was produced in 1777. So there's Blomidon. And notice how the Partridge Island rocks are just really vertical structures. And then you can see off in the distance Clark's Head and perhaps Wasson's Bluff in the far distance. But the geology is more just erosive columns of vertical pieces there. So that's from the western side, and we know that he painted that from the water because of where that view plane is. This next view plane, we have to pull back and go right above Ottawa House. Look out over top of the Partridge Island and see that this is where George Heriot's view was. And that orange exposure of sandstone is no longer there, showing the amount of erosion that's occurred in 200 years. Then we jump back to the other side to see this view plane from the surveyor, Wolford, and this water scene. and then onto the beach between Partridge Island and East Bay, where Alicia and Jeffries painted her scene with Cape Split in the distance, Cape Sharp, East Bay, and Partridge Island. And this image was done as a painting, and then this is a lithograph that was published in Abraham Gesner's book, Mineralogy of Nova Scotia. You can see the wharf is, not the wharf, the weir is depicted there. So this goes back to the 1840s. It is a bit nauseating, isn't it? Apologize for that. I used to have an art history professor who would describe his art history slides, and we're going to Rome now, so buckle your seats. That's a little too much, though. So here's a view that I have, or had, along the shore. And as a geologist, I'll just let you look at this as you will. You may be an artist. So again, I'm interested in drawing and what that can do to convey things. So I took a moment to do a drawing of this scene. So you can see the value of drawing is you can put a quick label on things. So there's Partridge Island in the far distance, and I know that's Crane Point ahead of us. But what is there on the beach is a large boulder. And so here's the first geology lesson. So you have a cliff, and a large rock falls off of it. And if you can put your arms around it, and bigger, it's a boulder. Okay? So that's a boulder. And if I have a rock this size, that's called cobble of rock, yes. So that's cobble. And then a cobble will break down to form
Pebbles.
a stone, but the grain is called a pebble. That's a pebble-sized grain. And then that pebble gets broken down so you can put it into a tiny little grains of
Sand.
So that's the rock cycle. Everything that is a rock is dedicating its life to becoming sand and silt. That's its mission. So this particular boulder, you can see I've drawn, is composed of cobbles and sand. And I know that those cobbles were once flowing down a river 300 million years ago on their quest to become sand. They were part of the cycle. They were on their way. And then they got buried and stopped and frozen in time for 300 million years. But before I came along, just before I came along, that boulder fell from the cliff. And that cobble that you can see I've labeled on the beach has been freed and is starting its journey again. So this is an erosive pattern that the rocks are doing. So that's the same scene, but maybe you look at it a little differently. It'd still be beautiful to paint, but there's maybe something else there. That these rocks have been frozen for 300 million years, and now they're active on the beach. A recent thought I've just had, which is quite absurd really to actually dedicate a lot of time to thinking about it, would be how long would that cobble survive on the beach? Like there's no practical reason to actually do a study to figure that out, but it would be cool to know. Like somehow geotag that cobble and follow it. How long do you think it would survive? How long does it take for that cobble to become sand, silt, and move out?
1,000?
Could be.
Couple months.
I think it's longer than a couple months. So you can also think about how long is those, if you're walking on a cobble beach, how long have they been there? How long is their journey? So this is an interesting, I think, map. This is the oldest geological map of Nova Scotia. It's from 1828. It's produced by two geologists from Boston, Charles Jackson and Francis Algier, who traveled into Nova Scotia during the Age of Sail. And you can really see that they put a lot of their focus around the shores. I'm zooming in very quickly to the Minas Basin. that we're focused on here. A lot of their knowledge would be based on the coastal cliffs because it's 1826. You're not digging a lot of wells or anything. It's really, you can only observe the coasts and the rivers and the coastal cuts. So each color in the geological map represents a type of rock, or now today we know much more about the ages of rock, so we can talk about how old a rock is, not only what type of rock it is. But this is the first one, so it's very simple. The colors are very simple, and the concepts are very simple. The legend on the bottom, if I could go back, you can see each color, it's arranged linearly. So they don't have our modern concept, number 2 geology topic, that something that's older is below, something that's younger above. This map, they're not thinking time at all. It's all, they still don't even know that it's millions of years. It's just rock types, and they're trying to understand where the different rock types are. So around this same time, 1826, Abraham Gesner, who had been born near Wolfville, and went off to study medicine, was the physician here in Parrsboro, or when Parrsboro was over by Partridge Island. He was the physician. And he was riding his house to do house calls, and he became interested in geology, and he became very interested in geology and studied the maps of Charles Jackson, French geologist, and he published a book called The Mineralogy of Nova Scotia, and that's where Alicia Ann Jeffrey's image was published. Abraham Gesner became very famous for inventing the distillation of kerosene, so lighting up people's lives in a real way.
He's lit.
The really big deal, though, was when Charles Lyell literally wrote the book on geology, the principles of geology. He is like the Darwin of geology. If you've not heard the name Charles Lyell, he was a really big deal. So he wrote a series of books called The Principles of Geology, which you've learned 2 of them. Boulder, cobble,
Pebble.
and
Sand.
sand. And what's older is below and above. And there's also the continuity of things. When you see something that looks the same as over there, then they must have been joined at one time. So all these principles, and most importantly, he was about, in order to understand what you see in the past, you have to look at the current and understand how cobbles roll down a river, to understand when you see a boulder full of cobbles, that was once a river and was frozen in time. So that was his great insights. He published the book in 1830 and was invited to give a series of lectures in Boston in 1841. So he travels to North America, gives his lectures, and then spends a year traveling around North America, so 1841 and 42. On his way back to England, he stopped in Halifax, because all ships stopped in Halifax. He got off the ship with his wife Mary, and they spent a month traveling around Nova Scotia. So you can imagine what it would have been like to have the person who literally wrote the book on geology and had been just lecturing and traveling around, seeing Niagara Falls and interpreting what it means. He's giving lectures and to see the person there, a woman, making notes and doing a little drawing. And by the way, for the young folks in the crowd, that's actually why it's called PowerPoint. It should have a stick just like that. So he travels around, and he then wrote another book called Travels in North America and Nova Scotia. Nova Scotia actually had 2 chapters, something like 180 pages devoted to it, that Charles Lyell is writing about the significant geological things that he sees in Nova Scotia. That's published in 1845. I've been working on a project where the University of Edinburgh has just purchased all of Charles Lyell's notebooks, 230 notebooks. And they've scanned them, and so there's 2 notebooks that represent his travels around Nova Scotia in 18. I've drawn the map of the route that he took during that month, and this is a poster I gave at a conference, and there's clip scenes of when he was at Joggins, which was a very significant thing for him, and Joggins is now a UNESCO World Heritage Site. So if you're visiting Nova Scotia and you're on your way back to the US, definitely stop in Joggins to check that out. So among his notebooks, this is an unpublished image, but this is when he left Wolfville on a ship with his wife Mary, and they landed at Partridge Island, which is where ships landed at the time. He got out of the boat and met Abraham Gesner, and before they got in the carriage ride to go up to Joggins, he did this sketch of Partridge Island. His handwriting's hard, Partridge Island, Parrsboro at the top, and he has dip 20 degrees west, 20 degrees south, and he has trap written on the right-hand side. So trap is a word that he would use to describe the salt, which you're going to know about in a moment. So that's a type of rock. He's talking about on the west end, the island is dipping in a certain way. So rather than De Vere's depiction of Partridge Island, just those vertical columns, he's depicting this. How are things related up on top of each other, and what way are they dipping? Because he didn't know why, but things can be tilted. And how would you explain things being tilted if you didn't know what we know today, which you'll know in a minute? Is really interesting. So anyway, I just yesterday went and I found the spot where he stood to do that drawing, and I had a nice experience. My dog was at his feet in the water as the tide was coming in. The wind was blowing quickly, and I just spent a few minutes just drawing, and it looks just like you can see where he's drawing those lines. It's wonderful to be able to stand in the place of giants. So another person that he met here in Nova Scotia, he spent time with, was William Dawson, and William Dawson would then go on to write the dedicated book on geology of Nova Scotia called Acadian Geology in 1855. Here's a depiction that Dawson drew of Economy Falls, and you can see the Victorian geologist in his top hat standing at the bottom there for scale. But Dawson's geology map was greatly improved over Jackson Algier's map of 30 years before. And then around 1890, you can see in the travel literature, so the book Frank Leslie's Popular Monthly, there's depictions of Parrsboro at low tide. So that is where Parrsboro was located, was at the Ottawa House. So while you're here visiting, I also encourage you to visit the Ottawa House Museum at Partridge Island. And that is where the main wharf was. Where we are here now in Parrsboro was called Mill Village, and it became Parrsboro a little bit later. So there's Parrsboro depicted at low tide. So even back then, the high and low tides were a big thing. And the geologists from the Geological Survey of Canada would have their picture taken in front of Partridge Island. So these are very famous folks there. The one second left is Hugh Fletcher, who is a very famous geologist that did a lot of work here. And then this Partridge Island was also the subject of tourism postcards, and it's likely because the geologists were the first ones to carry cameras, and it's those images that then became tourism images. So you see the linkages between why geology and tourism are often linked together. So we know our globe, we know it's round, I hope. So we're going to just roll it back, as Michael says. We're going to reunite Pangea, and we're going back 300 million years. This is a new concept. My dad, when he was in school, high school, this was not known. It was actually just coming out, the idea of tectonic plates and continental drift. But this is what Nova Scotia looked like right in the middle of the central part of Pangea, which means one Earth, one world. And this is the Carboniferous, so the Coal Age. 300 is one of the numbers you need to remember. It's an easy one. 300. 300 million years ago. Is where we were in the Carboniferous. Now, let's roll from there forward to 200 million years ago. Pangea stayed together as one unified mass for a long time. And I forgot to mention that during the Carboniferous, the major important thing was that's when trees evolved. Before that, plants were they didn't have enough vascular tissue, so they were dedicated to the river's edge. They didn't have enough vascular pressure to move away from a river. But during the Carboniferous, vascular tissue evolved, and then there was a war of trees to get above the others so that they were not shaded out. And that's when literally the world turned green. There was so much oxygen in the atmosphere, 20% more, that insects, dragonflies, could be as large as my arm because they breathe through their skin and they needed that extra oxygen. So that's when you're painting a scene that you know is the rocks are 300 million years old, think about evolution of trees and the world turning green. Now we've gone forward 200 million years, and it was not good. So for almost 500,000 years, or about 500,000 years, a huge amount of magma came to the surface and covered that area of the globe. And 500,000 years is fast. You just saw a lot of time pass in that animation, right? So this was not good. This caused massive global warming and a global mass extinction. And a lot of the large terrestrial predators were wiped out, but the small, little, tiny dinosaurs survived that mass extinction and then became what they became. So that happened 200 million years ago, and that's what we see in the rocks around the Bay of Fundy in the basalts, the trap that Charles Lyell drew. And so moving on from there, because of all of that rifting and lava coming forward, that's what's driving plate tectonics, is the magma underneath the continents, like a conveyor, like a lava lamp, moving the continents that are just a thin skim, almost like a skim on a black bean soup that's on a cool skin. It's so thin, it's hardly even there, but as it bubbles, it's moving around. So that's what we have here in the Cliffs of Fundy. We have the Carboniferous, 300 million years ago, and we have a series of geological formations that represent slightly different environments during that time around 200 million years ago. And those formations are usually named after where they're located, the type of rock is located. So the Wolfville Formation is the oldest of that group. The Blomidon Formation is on top of it. And on top of that is the basalt, the magma that cooled and wiped everything out. And on top of that is the deposits at Wasson's Bluff, where we find Canada's oldest dinosaurs. And all of that is represented in the Cliffs of Fundy. That's the coming together of Pangea and the ripping apart of Pangea. So the Carboniferous and the Geopark map, and as the artists are out there painting, you might go to East Bay, and those exposures, if you're looking at Partridge Island, you just turn around on your left-hand side, you'll see East Bay. Those are from the Carboniferous period. Those are sort of lake bed and fluvial systems. But that's from the time when trees evolved, when the earth turned green. Or down towards the Age of Sail Museum. Again, if you're down there, I really encourage you to go into the Age of Sail Museum and learn about the Age of Sail along this coast. And so the rocks exposed along the Greville Formation are also Carboniferous in age, very early Carboniferous. Anyone want to hazard a guess at what the formation is called of those Carboniferous rocks at the Greville River? Yes, you're right. Greville Formation. So those are a couple examples of the Carboniferous. Here's a couple examples of artists painting the Carboniferous last year.
Wow.
And Greville River. The Wolfville Formation, you would recognize as the really thick and bright red sandstones that are really what the Cliffs of Fundy are known for. Like, when you think of Cliffs of Fundy, you're probably thinking these beautiful red sandstone cliffs. So in terms of the boundaries of the Plein Air Festival, around Economy and Thomas County is where you would see those sorts of things. The Blominen Formation, which is on top of the Wolfville, and the basalt, which is on top of the Blominen, you can see in dramatic exposure at Five Islands, where you see the red sandstones of the Blominen Formation, which is different than Wolfville. Blominen is more playa lakes, so it's sort of like Salt Lake. It's drier, and that's the Blominen, the red sandstone there. And then on top of that are the basalts, and you can see the white where the basalts, as they came across the red sandstones, cooked everything and turned it that light gray. And now that they're eroding, they're sending that white color all down the cliffs. So that's beautiful exposure at Five Islands. It's one of the geosites of the Cliffs of Fundy. And the basalt is in many places along the shore. So it is at Partridge Island. That's what Partridge Island is made of. Lyell called it trap. That's what he thought that was the term at the time, but we now know it is basalt. It's formed from magma that cools when it comes to the surface. And Cape Dore, beautiful, beautiful spot where this whole talk started with the painter standing at the lighthouse there. So that's basalt. That represents the really bad day of the mass extinction. But now a beautiful one. So that's an overview of some sites. This is new research and relates to, that's where Wolfville is for the folks who are new to Nova Scotia. It's on the other coast of the Minas Basin. And I want to tell you about Professor Ernest Haycock, who is a professor at Acadia University, which is a very important university in Wolfville. And he studied rocks in Scotts Bay. So I've got that labeled there on the side. Very, very briefly, each of these topics is actually huge. Like I could write a book on each one. So I'm embarrassed to just give these little, but here we are. So Professor Ernest Haycock was born in the year of Confederation, 1867, down in Briar Island. He's the son of a sea captain. His dad's name was Maurice Haycock, very respected sea captain. Ernest Haycock went to Acadia University, then to Harvard for 2 years studying geology, and then came back to Acadia and was a professor of geology and mineralogy in 1900. One of the coolest things I've come across in my historical research is the essay he wrote for the inaugural address of students. He's just started as a professor. He's just finished at Harvard. He's coming back home, and he's giving this talk, and he's using the line from Shakespeare's play, As You Like It. And he's taken that line, the tongues in trees, the books in running brooks, sermons in stones, and good in everything, from a geological point of view. So, an example of books in running brooks would be what I told you about the boulder and the cobbles and things moving, and how long that took. And he's encouraging students to think about things on those sorts of time scales. You're looking at a cobble on a beach, but how long has it been on its journey? Tongues in the trees are about how long that evolution of trees has been. So he was a very powerful writer, and he inspired his students greatly. He had many, many important students came from Akita University during his time. And also in 1900, he went to Scotts Bay and he noticed that there was sediments on top of the basalt, not just below. So these are some of the earliest photos published in this journal, Nova Scotia Institute of Science, that he would have taken. But then this is his drawing of that same area, and I'll add some color so it's a little easier to see. So the blue is the basalt, the magma, the bad day. And then he's noticed that these other rocks are carved into and sitting on top of the basalt. And they would then become, not named by him, but they would become named the Scotts Bay Formation. So this was the first recognition that there was actually rocks of importance above the basalt. So he was the one that really put that all together. Wasn't planning on saying this, but this is a good time. One of the things for visitors who are new to this area, and you're going to be going to these beautiful beaches, and they are beautiful. He's drawn on the bottom of the cliff lots of boulders that have come down and some erosive stuff. So just pro tip, that's not where you want to stand. You admire that from a distance, because that means there's active stuff coming in. You should also be cautious when there isn't stuff around, because it may be the first time, but that's not where you have a picnic. I digress. So that was Ernest Haycock's important local geology. He did work for the Canadian Geological Survey, he did some work out in BC, and he did a lot of surveying around Quebec during the summers. His son, Maurice, was born in 1900. His wife, Priscilla, unfortunately died a few years later, leaving him with his only son. I'm sure he was quite heartbroken. He did still do geological work in the summers. And Professor Haycock died in 1918. His son, Maurice, continues the story because he also went to Acadia and studied geology. And he wrote his thesis, his master's thesis, on the geology of Parrsboro. None of my geology colleagues know him. This has totally flown under the radar.
Really?
No one has known this. So I pulled his thesis out of the archives and I photographed his map of Parrsboro. And this is a photo of Maurice. He's standing there on a rock. He's sitting on one of those rocks. You can barely see. So that's the falls at Harrington River. And he had a figure caption on that saying, "The picturesque falls of the Harrington River." A geologist is saying picturesque scene. So you know something is coming with someone who's saying that. And it was true. So that summer, fall, year of 1926, he went on an Arctic expedition and he met A.Y. Jackson, member of the group of 7, then went to and finished his studies at Princeton, but he maintained a friendship with A.Y. Jackson, so the two of them are painting here, Maurice Haycock and A.Y. Jackson. So visiting Americans who might not know, group of 7 were a huge deal in terms of the art history of Canada. A.Y. Jackson was one of the founding members. So Maurice Haycock and his daughter, Kathy, is in the audience, which is amazing, wrote a book about Maurice, and I encourage you to check that out. And here is Maurice at Blomidon with Kathy and her sister Carol at his side. In 1949, a geologist painting a scene at Blomidon.
Wow.
At Blomidon in the distance.
That's beautiful.
So what does that mean? This geologist who's worked for the Geological Survey of Canada, he's come home and now he's looking at these rocks, also with an artist's eye. It's just beautiful. Again, there's a lot more I could say with that. So this is another area I could say a lot about. So the tides. Why are the tides important? The tides have been important for mariners. They were been known for be the most powerful tides in the world for a long time. But really, what really made it important was in 1957, in August, National Geographic article called "The Giant Tides of Fundy," and it was a huge article, something like 90 pages, or 80 pages long, or something like crazy like that. And National Geographic, 1957. That's a pretty big deal. Like, there's nothing else like that would have that sort of range. And so it was an article that was written by a biologist. He's going around and looking at the phenomena of the Bay of Fundy, and it was really a travelogue for his family. His his daughter and son and his wife were there, and they're seen in a lot of the photos. They're just doing summer things around the Bay of Fundy, digging clams, but the geology's there in the background. There's images of the high and the low tides, and trying to depict. It is such an amazingly phenomenal thing in 12 hours, the movement that goes up and down. And Parrsboro was literally put on the map up there because one of the guides was Eldon George, who's up there in the top. And Eldon and his brother Willie with the key split in the background. So he was a mineralogist, and he had the Parrsboro Rock and Mineral Shop. And he was a guide. He would take people out guiding, he would take people fishing, but also mineral collecting. And another image of Eldon and his brother Willie. And oh my God, get those kids off the cliff. Not do that. Like if you look up from there, oh my God, get away. Anyway, this was a big deal. And for years, Eldon said, like 3 years, 4 years, every day during the summer, people would be coming into Parrsboro and into the shop with this magazine. They were retracing this family stuff. It was like TripAdvisor on steroids.
Tim, before you change it, that's a great example of tectonic upheaval.
Yep. And that's the Carboniferous at East Bay. Because Pangea came together and ripped apart, that's why things are tilted. And we know that today. Lyell drew the dips, but he wouldn't have known why. Now we know why. It's those collisions between plates and movements. So Eldon remained important, and that was also important for the time. A year later, the Spring Hill mine would have their great disaster, and the last load of coal would come from the Spring Hill mine down into what is now Parrsboro. So the area was devastated economically. But Eldon really leaned into the importance of minerals and tourism, and he really pushed that through his whole career, his whole life. It was all about tourism. And he had his rock and mineral shop, but he was always at the tourism events. He was always going down to Maryland, down to New York, during Maine, promoting Nova Scotia and coming to Nova Scotia. But he also worked with scientists, including Donald Baird at Princeton University and Paul Olson, who would go on to find the first dinosaurs down at Watson's Well. So Eldon was a force and an important contributor to the whole scene, to the whole making this area important. And from the discovery of the dinosaurs, the local community formed the Cumberland Geological Society, which formed a museum, a Fundy Geological Museum, which aims to be the world's center for experiencing the geological history of Nova Scotia's Bay of Fundy. That was all from, it's all the trajectory. It's all building on from Gesner, from Lyell, from the Haycocks, Eldon, everyone, we're all learning and building on each other. Geologists collect minerals, but it's also a collective science. It's intergenerational, you're building on people from the past. So Tom Forstall unfortunately passed away very recently, but he did these wonderful portraits of Eldon. He asked Eldon, what would he want to be known for? And it was this world's smallest dinosaur footprint, so he's holding up a medallion. Where did he want to be depicted? And it was East Bay in the background, because that's where he found his first fossil when he was 9 years old. And then the depiction of the rock shop and that very playful green dinosaur that he had out in front of his shop. And that you can still see at the Fundy Geological Museum. So that his collection and his shop were purchased by the museum, and for 3 years we worked on moving that over, so the green dinosaur now has a home over at the Fundy Geological Museum. But we miss Tom Forstall, that's for sure. So that's, and now I just want to wrap up quickly by telling you something that's very new and also very old. And it's from a site that's not even yet a geosite down at Spencer's Island, down on the western side of our geopark. When I was working at the museum in 2015, Michelle came into the museum because she knew that fossils are protected in Nova Scotia. They have been since 1980, so if you find a fossil, don't collect it, take a photo and tell us where it is. Fossils are protected in Nova Scotia. So if you see something, I won't repeat it 3 times, you got the point. She got the point, and she brought, well, she did collect it, but it was very important. She brought it to the museum and said, is this important? And certainly it was. As soon as I saw it, I'm like, yeah, that is totally a dinosaur toe bone, metatarsal. And it's heavily mineralized. It's got all kinds of tiny little quartz crystals in a little hollow that is all filled in with crystals. But when I looked at it, I'm like, yeah, that is definitely a bone. But it's weird because Spencer's Island is basalt. It's from that bad day, the magma that came to the surface. There's no fossil. You won't find fossils there. So that was 2015, and it was only last September that I was able to go out there. Here's a historical depiction of Spencer's Island from 1800, showing the distance away from the cliff. So that's Cape Sharp on the right-hand side, and Cape Split on the far right-hand, and the ships go through, and around the corner would be Parrsboro. So it's always been remote. Gesner was there, and he said that there's beautiful minerals on the beach. William Dawson, in his Acadian Geology, says, I've never been, I have no idea what's there. And on his geological map, he actually located Spencer's Island in the wrong place. So it's clear that he was never there. There's just so many other great spots to look. No one's really gone there. But we went last September. It took us 9 years. There was a pandemic in there, so give us that. But we went out, and it is beautiful. So Local Guide Ventures is down in Spencer's Island. He can do other things too. He's got big fat tire bikes. You can ride on the thing. He's got places to stay, and he can take you flounder fishing. But he took us out to the island, dropped us off, and we were looking around. And yeah, there are spectacular chunks of agate, which is a type of quartz that the Mi'kmaq used to fashion tools. But just look at that color, that orange iron oxide color that looks very similar to the bone that I was looking for. And very briefly, because we're onwards here, it does have these really beautiful columnar basalts, which means that that's the top of the basalt flow. But down on the far end, we were able to find about 20 meters of sediment, which would likely be Blomidon Formation that was just hanging on. In another 100 years, it's going to have been eroded away and lost forever. So there's reason to believe that that's where the fossil bone came out. And so we want to go back, and we will be going back this summer. So we have this toe bone, which now I'm confident came from there and is likely Triassic in age and would look something like this. This is I'm pushing. There are paleontologists in the room here, so don't help me out. This is pretty tentative, but it would probably look something like this, which would be an animal called Postosuchus, which would have been one of the animals that large dinosaur-like meat-eating animals that would have gone extinct that allowed the small dinosaurs to survive. So you see its back foot has these quite robust metatarsus. So that's cool. But then I went back to Silas Rand. Because I have a historical view and incorporate history in my research, because I have two-eyed seeing, I went back to Silas Rand and just didn't read everything. Control F, you do a lot of things. Control F, Spencer, boom, takes you to Silas Rand talking about Spencer's Island was Glooskap's kettle, made of stone. But he also recorded this story from Stephen Hood, who was a Mi'kmaq man who lived with his family in Mill Village in Parrsboro. Stephen Hood was a basket maker, and his father was a basket maker. But he was a very prominent, productive person living in Mill Village, which is now Parrsboro. And he said, Spencer's Island is his kettle turned over, and the scraps he shoveled out, Glooskap, shoveled out, while trying out his oil, still lie scattered around but turned to stone. 1867, a Mi'kmaq person from Parrsboro is recording that there's bones on Spencer's Island that have turned to stone. That's pretty cool. So it's not new to the Mi'kmaq, but it's new to us that we have this new fossil locality in the cliffs of Fundy, which will be important to do future work on. So another important example of value of keeping both eyes open. I borrowed images from different people, and I'm grateful, and would encourage you to take an opportunity to learn about Mi'kmaq culture. It is rich, and the Mi'kmaq Debert Cultural Center, I know we have swag here from PIPAF, which we want to do support, but also the Mi'kmaq Debert is fundraising for a new cultural center. I encourage you to throw $50 annual donation to them to make that dream come true. And then I'm just going to end by asking the artists who are here on social media, that image of Maurice and his daughters, and he's at the easel. If you've got something similar that you're doing while you're painting your easel on the site, why not, and you're posting on Facebook, why not tag at Fundy Geopark and hashtag PIPAF 2025, PIPAF 2025. That way we can all see the stuff coming out on social media. And I think that's it. That's the beginning.